Kia ora, Year 12. In this video, I'm going to go through again how to use the quadratic formula. So the quadratic formula is kind of like the sledgehammer approach to solving a quadratic equation. And we saw this in class today, but some of you watching this will have been away. So I'm going to look at it again. If we have a quadratic equation in this form here, so A, B, and C are the coefficients of those three terms, then I can find x in the following way. X works out to be equal to negative b, right? So this is b in here, this coefficient, plus or minus the square root of b squared minus 4ac. Now we're going to spend heaps of time in the next couple of weeks talking about what b squared minus 4ac tells us. But today the purpose of this video is just to get you used to mechanically solving these equations. And then we take that numerator and we divide it all by 2a. And so a is this coefficient here. Now we use this quadratic formula when we can't factorize the quadratic. And I'm going to go through 4 examples in this video. I want you to have your calculator ready because all 4 of these examples, well, actually 3 of them, are ones where we can't factorize easily. And we should always look first to see if we can factorize. So this first one, I need to change that equation a tiny bit because it should say x squared minus 8x minus 18 is equal to 0, right? So if we take a look at that, we can think about whether we can factorize that. We're going to have an x and an x, and we've got factors of 18. So we want to have something times something equals negative 18. So we're going to have a plus and a minus, and we want the gap between those two numbers to be 8. So it doesn't work very well, right? I've got 1 and 18, 2 and 9, and 3 and 6. So from a quick look, you can see this isn't going to be a nice quadratic equation. So we're going to use this to practice the quadratic formula on. So let's look at how we set it out. So I always start by writing down what's A. So A is 1, the invisible coefficient in here. A is 1, B is negative 8, and C is negative 18. Then I substitute those into my formula. So we'll write down the formula to get our brains used to it. And then we're going to substitute in. So negative 8 gives me just positive 8. Right, so there's B, and I want the negative of that. So 8 plus or minus the square root of this squared. So be really careful here. Negative 8 squared is positive 64. So write it out in full the first couple of times you do it. So minus 4 times A, which is 1, times negative 18. And that's divided by 2 times 1. Now we're going to clean that up. So x is equal to 8 plus or minus the square root of 64 plus 72 divided by 2. And that gives us this. So the 8 divided by 2 is going to be easy. That's 4 plus or minus the square root of 136 divided by 2. Or another way to write that is just 4 plus or minus 1/2 times the square root of 136. When we put this in our calculator, we can get an approximate answer. So we get x is equal to 4 plus or minus 5.8. Oops, don't know where the pen's gone. Let's just see if we can get it back working. Oh, this whole thing has crashed. It's not very good. Right, where's it gone? Okay, sorry about that, guys. I have no idea what just happened. It did that a little bit in lockdown last year, so now we've got it working. So it's 4 plus or minus 5.831. Now we need to go on our calculator. X equals 4 minus this number, which gives me negative 1.831, or x is equal to 4 plus that number, which is 9.831. And you can see that I've got 2 solutions here. And you're getting 2 solutions because of this thing here, because I'm doing a plus or a minus, right? So when I do my 2 solutions, when I do my plus or minus, I've got a number here. I'm talking about that now because we're going to spend time looking at when do we get 2 solutions to a quadratic. two real solutions, or when do we get one, or when do we get no real solutions. But for now, let's look on to number 2, example number 2. It's going to go the same way. So pause the video and just try and work through it, substituting into the formula and seeing what you get. So we've got x squared plus 4x minus 6 equals 0. X squared plus 4x minus 6 equals 0. A is 1, B is 4, and C is negative 6. Substituting in, I get x equals negative 4 plus or minus, so B squared is going to be 16 minus 4 times A, 1, times C, negative 6, and that's divided by 2 times 1, which is 2. So we have x is equal to negative 4 plus or minus the square root of 16 plus 24, so the square root of 40 divided by 2. That gives us x is equal to negative 4 plus or minus 6.325 over 2, and I should get these two answers. So x is equal to negative 5.162 or 1.162. Now I want to show you what the graph of this function looks like now. Partly for this algebra topic, but also for our graphing topic coming up soon. So we know that this is going to be a parabola, and we know a little bit more than that. If you think back to year 11, if we write it as y equals x squared plus 4x minus 6, we can easily find in here the y-intercept. The y-intercept is going to be at negative 6. We get that by substituting x equals 0. So what we're saying is that when x is 0, y is going to be down here at negative 6. And these two things here, remember, are my x-intercepts, right? So they're telling me that the parabola goes through here and here. So let's just check that that is what it looks like when we put it into GeoGebra. So this is it here, right? So this is x squared plus 4x minus 6 is equal to y. And you can see it's crossing at negative 6 here. This one here is my 1.162, and this one here is my negative 5.162. Right, so notice that it's got these two distinct x-intercepts, which we're going to call two distinct roots. And we found those using the quadratic formula. Sometimes we'll find them from factorizing. Okay, back into just how we do the formula. Right, example 3, give it a go on your own. So this is pulled out from the other video. Remember that this is in the wrong format to solve a quadratic equation. So we have to start by fixing it up. We'll have x squared plus 5x plus 6 equals 5. That gives us x squared plus 5x plus 1 equals 0. Can't factorize it. Have a quick look and give it a go. It's going to be very messy because I've got a plus, looks like I've got a plus 1 in here, and then I don't know what I've got here, but it's not going to give me 5. So we're going to try the quadratic formula on it and see where we get to. So a is 1, b is 5, and c is 1. X is equal to negative b, so negative 5, plus or minus the square root of b squared, 25, minus 4 times a, 1, times c, 1, divided by 2a, which is 2. Just get rid of this mess. There we go. Okay, so that gives us x is equal to negative 5 plus or minus the square root of 21 over 2. And put that in your calculator, see what you get out. An approximate answer to that one is negative 4.791 or negative 0.209. So that's that one done. Now let's look at the graph for it. Yep, that looks good. Okay, so we've got x squared plus 5x plus 1 equals 0 is what we're solving. And you can see that one of those roots is here. That's the one at negative 0.209. One of the roots is over here at negative 4.791. And you can also see that my y-intercept is here. You're going to need to get really, really fluent with sketching and interpreting quadratic graphs for the graphing internal, so it's good to get used to it now. Right, one more example to do. This last one, 5x squared plus 3x minus 2 equals 0. We can look at that. Now this one we actually can do by grouping, so you might want to try that for some grouping practice. Or we can go straight to the quadratic formula. So a is 5, b is 3, and c is equal to negative 2. Always write that down before you start so that you don't muck up the calculations. X is equal to negative 3, negative b, plus or minus the square root of 9, so that's b squared, minus 4 times a, 5, times c, negative 2, divided by 2a, which is 10. That gives me x is equal to negative 3, plus or minus the square root of a very nice square number, 49 over 10. So in this case, x is equal to negative 3 plus or minus 7, all divided by 10. X equals negative 10 over 10, or x equals 4 over 10. Simplifying that gives me x equals negative 1, or x equals 4/10, which is 2/5. And this is one of the few times in maths that we really do like to have decimals. Okay, so x is equal to 0.4. Let's just quickly look at the graph and see if that fits. Yep, here it is here. Okay, so 5x squared plus 3x minus 2. This is y. You can see the y-intercept on here. You can see the 0.4 root, and you can see the negative 1 root. So there you go. Look, the quadratic formula is one of those things that is really tedious. Okay, and it is like a sledgehammer. If we can do factorizing easily, then it's always going to be faster. But this quadratic formula gets us out of lots of difficult situations when we're working with quadratic equations. So it's really important that you are confident with using it. Thanks for watching. This has been quite a long video. So just now go and do some of the quadratic formula ones that are in either theta or the Walker workbook.